Welcome, learners. My name is Mr. Paul Chilola, your teacher on this platform. Welcome to Chemistry Revision. We are still looking at papers, especially the 2026 mock papers. So this is continuation of the paper we already began looking at. This is a paper that was written by schools in Central East Education Division. This is Chemistry Paper 1. So since we are simply continuing with what we already had begun, without wasting your time, let's look at question number 3D. Mention an alloy that is used for making surgical instruments. This is a 1-mark question, requiring you to simply state an alloy that is used for making surgical instruments. Welcome, learners. So in the first place, it is important for you to understand what is meant by an alloy and what is meant by a surgical instrument. What is an alloy and what it means by surgical instrument. So unless you understand these two keywords, it will be difficult for you to give an example. So what is an alloy? An alloy is simply a mixture of two metals, or it is a solution of a metal and another metal. It's an example of a solid mixture. So it's a metal mixed with another metal, or metal mixed with some kind of a non-metal, such as graphite being mixed with steel or iron, in order to produce a material that combines the properties of both. So surgical instruments are instruments that are used in surgery, in medical operations, like surgical blades. Surgical blades are example of surgical instruments. Some surgical needles and others. And such materials need to have the properties of being strong, the properties of being able to be sharpened, and also the properties of being non-corrosive. So such an alloy that combines all these properties is stainless steel. So a very good example of an alloy that can be used for making surgical blades or surgical instruments is stainless steel. This is 1-mark question. All right, so that was question number 2D. We come to question number 3 now. Study the organic compounds A, B, C, and D, and answer the questions that follow. All right. So we have these compounds. All of them are organic compounds. Remember that organic compounds contain carbon and the hydrogen, but the main element is carbon, which qualifies a compound as organic. All right, so just a quick identification of these. Let's identify A. Compound A is basically an acanone. It's an acanone. As a matter of fact, it's a propanone. Remember that a propanone has a carbonyl group which is bounded by two alkyl groups. So we have a methyl here, another methyl. Between the two, we have a carbonyl group. That's this is an acanone, also known as ketone. So this is a ketone. If you look at B, when you have a carboxyl group between two methyl groups, we have a methyl group, alkyl group this end, and another alkyl group over there. In the middle, we have a carboxyl group, something like a carboxyl group. This must be an ester. Is an ester or an acanoate? Acanoate. As a matter of fact, this is ethyl or methyl ethanoate. This is a methyl ethanoate. Or it could be ethyl ethanoate. Ethyl ethanoate. So we have the acid part and an alcohol part, making an ethyl or a methyl. I beg your pardon, this is ethyl ethanoate because we have two carbon atoms here, which makes it ethyl. And the other end too, we have a two carbon atom hydrocarbon part. Therefore, this is ethyl ethanoate. It's an ester. And then over here we have an acid. This is ethanoic acid, which is an acid found in vinegar. And then we have an alcohol, which is basically ethanol. So that's the names of these compounds, organic compounds. So let's look at the questions that we need to answer using them. Name the compounds A and B. So we already had named A and B when we were looking at them at a glance. All right, so A, like I said, is propanone. Propanone. Remember that for ketones or alkanones, a carbonyl group is bounded by alkyl groups. So we have a methyl group there, another methyl group this side, this, and then we have the carbonyl group. So you just count the number of carbon atoms, including the one in the functional group. So we have 1, 2, 3 carbon atoms. That makes it propanone. That's propanone. And we said that when you have two oxygen atoms between the two alkyl groups here, it means you are looking at an ester or what is known as ethanoate. So this is an ethyl ethanoate. Ethanoate. So we have named the two. And take note that each is 1 mark. Simply naming. We are simply naming the two compounds. All right. Give the use of compound, any two uses of compound D. This is ethanol. Ethanol is multi-purpose liquid. It can be used for a number of purposes. You're just asked to name any two. So in this case, it can be used as a solvent. Ethanol can be used as a solvent. It can be used in varnishes, making varnishes, inks. In all these substances, it's acting or it's being used as a solvent. Glues can also be added to alcoholic drinks. Remember, ethanol is a substance that's responsible for drunkenness in alcoholic drinks. It can also be used as a fuel to run car engines. It is also added to perfumes, any of these, but suffice to say that most of these uses, it's working as a solvent, except this use here, which is where it is being used as a fuel. It can be burnt to produce energy. Welcome, learners. My name is Mr. Pochilola, your teacher. We love to be here with you to prepare you for MSCE exams, which are much, much closer now than we have been talking. Come June, just in a space of a month, you'll be sitting for your MSc exams. So take advantage of these lessons to prepare fully for your MSCE exams. In case you have questions, don't hesitate to reach out to ask questions. We'll be glad to come back to you with the responses. Welcome once again. Invite your friends who would like to get similar assistance from us. Simply subscribe to the channel and we'll be glad to have you notified every time a new video lesson is uploaded. Describe how you distinguish C and D. Let's go back to the substances again. The cell C is an acid. It's a carboxylic acid. Carboxylic acid, also known as alkanoic acid. All right, take note. How do you know that? It has a COOH as a functional group. And then we have this as an alcohol with OH. So how will you distinguish the two? What experiment would you carry out to show the difference between them, between an acid and an alcohol? Welcome, learners. So in order to do that, all you have to do is put a sample of sodium hydroxide in a test tube. Put some drops of sodium hydroxide, but you have to be careful because sodium hydroxide is corrosive, so handle it carefully to avoid being burned. Alright, so put a sample put a sample of sodium hydroxide into a test tube. That's 1 mark. Then add the phenolphthalein indicator to it, another mark. Then add this sample C and D separately, not at the same time, in each test tube and observe. That's 1 mark again. C, which is an acid, will turn colorless, while D will remain pink. Remember that acids react with bases. Sodium hydroxide is basically an alkaline solution, so it will react with the acid, and in the course it is going to decolorize. It's going to decolorize the phenolphthalein indicator at a point called the end point. So this is some kind of neutralization reaction which doesn't happen with an alcohol. So take note again. You get a sample of sodium hydroxide put into test tube, add the phenolphthalein indicator to it. A pink color is going to appear, and then separately you add sample C and observe, and also add this sample D and observe the color change. It will be observed that C will turn colorless. Why it turns colorless is because the acid, which is in this case the ethanoic acid, is going to react with the sodium hydroxide, thereby decolorizing the sodium, the phenolphthalein indicator that was put into it, to turn from pink to colorless. Welcome, learners. Number 4, define the term weak base. Weak base. A weak base is one A weak base is defined as that which ionizes partially, not fully, in water to give few hydrogen, few hydroxide ions. So it is a base that ionizes partially. Examples include, but not limited to, ammonia. Ammonia is a weak base. It is going to ionize partially, only partially, in order to form few hydroxide ions. This is a definition, so it has 1 mark to it. For B, below is a chemical reaction, a chemical equation, where we have hydrochloric acid HCl reacting with ammonia NH3 to give ammonium and chloride ions. Take note. So we are supposed to use this equation to answer questions. Alright, so identify 2 conjugate acid-base pair. Remember that conjugate acid-base pairs are species in this kind of equation which differ with just 1 hydrogen atom. Species that differ with just 1 hydrogen atom. So in this equation, you'll appreciate hydrochloric acid, HCl, and the Cl. They only differ with hydrogen. There's 1 hydrogen here. Well, this one doesn't have a hydrogen. Therefore, this is 1 pair. hydrochloric acid and the chloride ion, a pair of acid-base pair, a conjugate acid-base pair. Remember that the acid is mentioned first, followed by its conjugate base. And another one is ammonium and the ammonia. Ammonium has 4 hydrogen atoms. Ammonia has 3 hydrogen atoms, therefore the difference between them is a hydrogen. That's how you'd recognize the conjugate acid-base pairs. Take note, here ammonium is taken to have, is considered to have the tendency or the ability to give away 1 hydrogen in a chemical reaction. As a matter of fact, that's what it's doing. It is going to give away 1 hydrogen to chloride ion in a backward reaction, so that you have HCl and you have H3 and H3 remaining. In this case, ammonium is acting like an acid. Remember, an acid, according to Bronsted-Lowry's theory, is one that donates hydrogen. So in this case, ammonium is acting as an acid. That's why it has to come first here. If you write ammonia first and followed by ammonium, wrong. You'll be given a fair mark. You'll be marked wrong. Welcome, learners. This is Black Slides Online, your school. Define an amphoteric, the term amphoteric oxide, amphoteric substance. Remember that some substances may behave like acids under certain conditions and as bases on different conditions. Such substances are called amphoteric substances. So we are saying, we are defining amphoteric oxides as oxides that have both properties of acid and bases in different conditions. Amphoteric substances having 2 properties, the same substance behaving as if it's an acid and the same substance behaving as if it's a base. Water likes to behave like that. There are also some people with amphoteric behavior. Sometimes they can be good, at other times bad people. That's just by the way. Welcome, learners. So give 2 examples of amphoteric oxides. Two examples of amphoteric substances. We have aluminum oxide, zinc oxide, and lead oxide. These are examples. Make sure you know all of them so that you can give any 2 in an exam. Explain how each of the following prevents rusting of iron. Tin electroplating, tin plating, coating a metal with or iron with tin. How will it prevent rusting? Remember that rusting is the formation of an oxide. Also, formation of an oxide on iron is called rusting. So you can prevent rusting by before that, let's look at this question here that says mention any 2 conditions for rusting. For a substance or iron to rust, there must be water and air, such as especially oxygen, but also the presence of sodium chloride, in case they ask you for 3. So you'd also mention add sodium chloride. Sodium chloride, which is salt, facilitates rusting. Explain how tin plating or coating iron with tin would prevent rusting. So iron is covered with a thin layer of tin. That's one mark. And in so doing, iron is prevented from reacting with oxygen and water, because tin basically is non-reactive. It doesn't react with oxygen. Therefore, when iron is covered with tin, the iron will be prevented from rusting. Welcome once again. So we are done with question number 5. Next time when we meet again, we'll look at question number 6 and the others on the same paper. Bye-bye for now.